Hello friends, welcome back to my channel. This is Mr. Soyen Chutke, today helping you with metals and non-metals. So in this chapter, we are first initially going to study about the difference between metals and non-metals, and later on we are going to move on to how these metals can be extracted. The term used for that is metallurgy. So in this chapter, metals and non-metals, like if you even look around yourself, you will find many objects which are made up of metals as well as non-metals. Now if you look at say for example this pen, so this pen is made up of plastic, okay, and it is a non-metal. Okay, then if you look at this ring, okay, so this ring is metallic, it is made up of a metal. So there are many things which are around us and they can be classified into the metals and non-metals. Even our periodic table is full of such kind of elements, that is metals and non-metals. So in your periodic table, if you observe, there is a diagonal in the P block, okay, there is a diagonal in the P block, okay, and there you will be able to find that, see this diagonal, can you observe this yellow and blue line? Yeah, this is the diagonal. So all elements which are placed on the left hand side of the diagonal are metals, and all elements which are placed on the right hand side of the diagonal are non-metals. Okay, so when I'm talking about these metals and non-metals, do you mean that the 85% of the periodic table is full of metals? Yes, we are having alkali metals, alkaline earth metals, transition metals, inner transition metals, then we are having your P block metals, but ultimately they are metals, but they are different kinds of metals. And on the diagonal you will be able to see that there are metalloids, and to the right of the diagonal you'll be able to see non-metals. So when 85% of the periodic table is only metals, can we say that metals are more abundant in the universe? No, they are the non-metals which are more abundant in the universe. And because non-metals are more abundant in the universe, okay, you can find them on the right hand side of the diagonal. This diagonal, on the diagonal we are having some elements like silicon, germanium, arsenic. These are metalloids. Okay, these metalloids are having properties of both metals as well as non-metals. They're having properties of both metals as well as non-metals. Now let's come back to our PPT, wherein we are going to see the difference between metals and non-metals, right? So just now we had seen the periodic table wherein we are having 118 elements. On the basis of their properties, we can classify them into metals as well as non-metals. We've seen that. Then yeah, what is this? This is silver, it's a metal. Gold, it's a metal again. Iron nails, metal again, right? Then have a look at non-metals. Sulfur is a non-metal, copper is a non-metal, right? Carbon, copper is a metal, carbon is a non-metal, chlorine is a non-metal again, right? So you can classify these elements as metals as well as non-metals, and you can find many things around you which are both, which can be either metals, non-metals, and some elements which are metalloids, okay, which are having properties of both metals and non-metals. Now you must be wondering how silicon is a metalloid, how it is having property of both metals as well as non-metals. Now say for example you take a chunk of silicon and you hammer it. Okay, and when you hammer it, it breaks into pieces. This is a property of a non-metal. It's a property of being brittle. It will break into pieces just like a non-metal. But if you try to conduct electricity with it, it will be able to conduct electricity, but the conduction of electricity will be weak. The bulb will not glow brightly, but it will glow dim. This indicates that it is having some properties of metal. So it's having some properties of metals as well as non-metals. Okay, so that is what a metalloid. But on the other hand, if you beat up a metal, you will find that it does not break into pieces, rather it flattens up into sheets. It can flatten up into such thin sheets that these metals can be used for coating of sweets also. You must have seen Kaju Katli, right? Aajkal to wo nakli chandi use kar rahe, but originally, I mean Raja Maharaja ke time pe pehle, we would actually have a flat sheet of gold or flat sheet of silver coated on metals, okay, or on sweets. Okay, so these were having the remarkable property to be beaten up into small sheets. Okay, then this property is called as malleability. Okay, the property of being beaten up into sheets is called as malleability. Then they also have a remarkable property of converting into wires. If you apply tensile strength to a metal, it will convert to a metal bar. Slowly it will start flowing and it will start converting into a thin wire. That is called as ductility. Now gold is an element which is the most ductile. Okay, gold is an element which is the most ductile. I think a few grams of gold can be converted into, where did that slide go? We just missed out. Just a second. We can convert into 2 to 3 kilometers, right? 2 kilometer long. Just 1 gram of gold can be converted into 2 kilometer long. okay, 2 kilometer long wire. So that is the ductility. Then metals also have a unique property of conducting heat. Now say for example we have lit up a burner. Here we are having aluminum rod. When this aluminum rod, this part will get heated, slowly the heat will be passed on, and hence we can say that metals are good conductors of heat. Okay, then we can also say that silver is the best conductor of heat, followed by copper. That's why some of the vessels in our home are having a bottom of copper. Okay, we don't cook food in copper vessels because it is having a chance of copper poisoning. We have to coat it, or else we have only the bottom made up of copper so that it can conduct heat better than steel. Okay, and better than copper is silver is the best conductor, but it's slightly towards the expensive side. Now the poorest conductor of heat among metals are lead and mercury do not conduct heat that very well, being although they are metals. Now the cooking utensils and water boilers are usually made up of copper or aluminum. Okay, so again, when you are using these vessels, you cannot directly cook food in them. You have to coat them from within so that the ions of aluminum and copper do not enter your food, because aluminum will cause aluminum poisoning. Okay, now the physical properties of metals. We are going to have a look at some physical properties of metals. They're good conductors of electricity, we have told you. Now, why are they a good conductor of electricity? Now, have a look. Say, for example, we are having a metal block, and in this metal block we are having the positive charges suspended in a sea of electrons. Sea यानी कि समुंदर, right? The positive charges are suspended in a sea of electrons. Okay, that means there are many electrons which are free. Okay, free electrons are here, and because it is suspended in a sea of electrons, these free electrons are able to move, and because they are able to move, they can conduct electricity. Right, they can conduct electricity. Okay, so you are having positive charges suspended in a sea of electrons. If you're not able to see, I'll rather show it to you over here. Okay, yeah, I think you will be able to see better. So these are the positive charges suspended in a sea of electrons. That means there will be many free electrons which are there, isn't it? So these electrons will be able to conduct electricity. Right, what do we require for conduction of electricity? We require free electrons. When there are free electrons, this can conduct electricity. Okay, flow of electrons is possible, it can conduct electricity. For the same reason, because there are free electrons, these can also conduct heat. Okay, and if you rub these metals, they will start shining. These electrons will move on to the excited state and they will start shining. Okay, so that's the reason. The free electrons are the reason for conduction of heat, conduction of electricity, and luster. Luster is the ability to shine. Okay, so coming back to the PPT, here we are having the first property that they are good conductors of electricity. You can see that with paper, the bulb will not be able to glow because paper is a non-metal. Whereas if you take an aluminum foil, the bulb will glow. Why? Because aluminum foil is a good conductor of electricity, and silver is the best conductor of heat as well as electricity. Okay, electric wires are made up of copper or aluminum. Why copper? Why not silver? Because silver is the best conductor. So why not silver? Silver is too expensive. अगर silver के wire बनाओगे चोरी हो जाएंगे. ठीक है? So we don't make wires of silver. Then metals are lustrous or shiny. Then they can be polished. Hence they are used in jewelry. Okay. Then metals are generally hard, okay, except for sodium and potassium. See, sodium, potassium इतने soft है, golden, मतलब lightish yellowish color के रहते हैं, and they can be cut with a knife also. Okay, they can be cut with a knife as well. That is the level of softness in sodium and potassium. Okay, but the other metals are not soft. Okay, as soft as they are pretty hard. Okay, so I mean, because they are hard, we can use them in different you can say infrastructure materials because they have integral strength. Okay, then sodium metals, except for sodium and potassium, okay, all metals are hard. Even mercury is not very hard, right, because it's a liquid at room temperature. So metals are generally solid, but mercury is a liquid at room temperature. Then metals have high boiling and melting points. Okay, metals have high boiling and melting points. Okay, except sodium and potassium are having low melting points. Even sodium, potassium, and mercury, except for these three metals, they are having low melting points. But because otherwise, metals are having a higher melting point. They are having high densities as well. Again, exception will be sodium and potassium. Sodium and potassium के atoms थोड़ा loosely arranged है, and उनमें intermolecular forces of attraction, interatomic forces of attraction भी थोड़ा कम है. जिसकी वजह से क्या हो रहा है? Sodium is melting also fast. Sodium is having a low density. Sodium is soft. Okay, whereas other metals are not soft, they are solids and they are hard. they're also having a good melting point, high melting point. So metals are also sonorous. Now you must have seen this bell. Okay, when you ring a bell, what happens? It produces a ringing sound which can go on. That sonorous resonant sound is being produced. Okay, so metals are sonorous. So if you tap a non-metal, right? If you tap a non-metal, see non-metal with a non-metal, it is, you can hear which kind of sound it is producing. Okay, but if you tap a metal like that, it will produce a ringing sound. Say for example, a coin falls on the ground, so it will, the sound will persist for a longer time. Or when your school bell goes, right, it will persist, the sound will persist for a longer time. That is called as resonant sound. Okay, that can be produced only by metals. So metals are sonorous. Now let us talk about non-metals. Okay, so non-metals are neither malleable nor ductile. They cannot be malleable, they cannot be ductile. They are brittle, they will break into pieces if you whack them with a hammer. Then non-metals do not conduct heat and electricity except in the form of graphite. So sulfur will not be able to light the bulb, but graphite will be able to light the bulb. Okay, so non-metals are non-lustrous, they are dull. Okay, except for diamond. Diamond is not dull. Okay, diamond is an exception. Okay, diamond is lustrous. Then non-metals are generally soft, except carbon in the form of diamond is very hard. So other metals, even if you break graphite you can break easily, but diamond you cannot break easily. Why? Because diamond is the hardest substance. अब ध्यान से सुनना कि इसमें the bonds present in metal are metallic bonds, but the bonds present in these organic compounds, or you can say the non-metals, are generally, you can say, covalent bonds. And these covalent bonds are generally very weak. They're having low melting point, they are soft, they are not solids. But if they enter into a network kind of structure, if the covalent bonds enter into a network kind of structure, they become very hard. So much is the hardness that it becomes the hardest substance on the earth. That is 3550 degrees Celsius is the melting point. It is also having a very, because देखना कभी भी जगह अगर कोई भी चीज बहुत ज्यादा हार्ड है तो उसको ज्यादा टेम्परेचर सप्लाई करना पड़ेगा. मतलब उसका IMFOA या इंट्रा एटॉमिक फोर्सेस ऑफ अट्रैक्शन, इंटरमॉलिक्यूलर फोर्सेस ऑफ अट्रैक्शन बहुत ज्यादा स्ट्रॉन्ग है. ठीक है, इतना स्ट्रॉन्ग है तो उसको सेपरेट करने के लिए भी हमको ज्यादा हीट सप्लाई करनी पड़ेगी. एंड बिकॉज ऑफ दैट they have a very high melting point as well. So diamond is having a melting point of 3550 degrees Celsius to be precise. Then graphite is also having a very high melting point. Uska bhi network structure hai 2800 degrees Celsius. So non-metals are not strong. They're easily broken except for carbon in the form of diamond. Okay. Then you can see over here, non-metals may be solid, liquids or gases. Sulfur is a non-metal which is solid. Like metals, unlike these metals were all solids except for mercury. But यहाँ पे sulfur is a solid, bromine or chlorine can be a liquid. Bromine is a liquid, and chlorine is a gas. Okay, so these are the different states of non-metals. These are what? Different states of non-metals. The non-metals have comparatively low melting point. Again, exception will be diamond. Okay, which will be having a high melting point. For example, melting point of sulfur is 115 degrees Celsius, which is quite low, but that of diamond is, I told you, 3550 degrees Celsius. Okay, the non-metals are non-sonorous. They will not be able to produce a ringing sound or a resonant sound. The non-metals have different colors. Non-metals have different colors like this. You can see sulfur is yellow, phosphorus can be red phosphorus, white phosphorus is also available. Graphite is dark. Then we are having this as white phosphorus, bromine reddish brown, and chlorine is pale greenish yellow. Okay, so now we'll move on to the chemical properties and reactivity series of metals. Okay, so now I'll put a link in the description of how to remember the reactivity series. I've given a mnemonic for remembering the reactivity series. Uska link मैं description में छोड़ देता हूँ. Please watch that video. I'll give you a trick on how to remember the metal activity series. Okay, now I'm going to explain how this metal activity series works, but we'll do that in the following video, following part of this series. Okay, but don't forget to watch the video on how to remember the metal activity series.